Hi, my name is Benjamin Drillings, and today I'm going to be talking about the seventh lab for microcontrollers, the LCD lab. And in this lab, we had to go over three programs. One recording a 4-bit mode LCD. Second was 8-bit mode LCD, and the third one was we got to choose, but I chose 4-bit mode LCD with a 4-bit binary input. So here we go. This right here is the 4-bit mode LCD. There's a delay of 1 second between it flashing on at the hello and flashing off. Additionally, it's all uppercase. Just remember that because the 8-bit mode is lowercase and flashes with 1 second and then delays off for half a second. So it's seen here, and we can visualize what's going on here using this flow chart over here, where we have a 4-bit mode, we're initializing the LCD, we're displaying it as hello, delay a second, clear, and delay another second. So there's that. Now if I go back here, I remove the file, yes, and then I add the second one. I can build it, I can load it, and if I reset, you'll see that the lowercase hello comes on and noticeably is quicker on flashing back on than the other one. This is the 8-bit mode, and it can be seen here. And then you can see this being visualized over in our flowchart. 4-bit mode, and there was figure 8 was our 8-bit, yeah. 8-bit mode, initialize the LCD, output hello, delay a second, clear LCD, and delay another half second. So, yeah, that can be seen there. And if we actually go up here, back here, you'll notice there's also a difference in the circuitry of these two. I kept them the same, actually, using the 8-bit. So the circuit that you see is for actually the STM, the input with the 8-bit connected, but it runs through all of these circuits. So this dip switch connected with this can run through this right here, and this right here. So this is the circuitry for the 4-bit mode. As you can see, it's only using the last 4 pins, PB7, PB4, PB5, PB6, and PB7. PC4, PC5, PC6, and PC7. And this is PB7, so something different altogether. And over here, for the 8-bit, it uses all 8, but it adds now the first 4 that we missed. And then here, you can see that we're going back to utilizing our last 4, so PC4 to PC7, and then PC8 to PC11 I set as for the dip switches. And the way that I was able to get the LCD reads it in ASCII, so all I had to do was shift the input to the least significant nibble, as you can see in the code here. All I had to do was I had to shift it, mask it, and then add it with 30, because it would give me the ASCII version of that, and it works for numbers 0 through 9. And then it starts giving me weird symbols, and you'll see that in a second. So let's remove that. Yes. Source group 1, add existing file. And it's custom LCD. So now I'm gonna load. I'm gonna load. And now you can see right here, I'm flashing on 0. Now the way that I have it configured is the 1 is the least significant bit, and the 8 is the most significant bit. I know usually it's not like that, but just for my sake, it was easier for me to reach the buttons. So as you can see, a 1 flashes on right there. If I do 8, 8 will flash on. If I do that, see, this is when you start to get those weird decimals, because ASCII after 9, it starts to go to characters. So yeah, and then if I do all of them down, I get question mark. So yeah, cool stuff. Going into, so for here, right here, these are actually connected to pull-up resistors. So essentially, whenever you get a 1, or depending on what is fed back to here, it will then output something else here. We also have a potentiometer here. This works for all of them. It can dim and brighten it, just to show you that that's connected all right. I also found that the RSW port, where is it? The RW port right there doesn't need to be connected for the 8-bit or the 4-bit to work. I just ran all 3 of these without having it connected, 4-bit, 8-bit, and 4-bit with a 4-bit input, and you didn't even need it. I'm not sure why that is the way it is. I just put it to ground over here. As you can see, this green wire is connected to RSW. It's RW, and then it feeds back and is connected to ground. So yeah. Additionally, the only difference thing that we did from the textbook, other than, make this an user input, is we just reuse this 16 megahertz cystic cycle rather than the one that they gave us. So yeah, that's all. That's the visual representation of this, and I hope this was shorter than most of the videos I do, and I hope that this was as educational. Thank you for watching. Bye-bye.